all the problems we've been doing so far, right, they give you an interest rate which is quoted like per month or per year, and then you're also given a time period which is in months or years, and those two kind of are always the same: the compounding period, the interest rate over the same period, and the cash flows over the same period. So now today we're going to look at what happens when you're given the information in different formats. Like you're told that a loan is over 30 years, but then the payments are made monthly, and the interest rate is quoted over a year as APR format. So we have to do some conversions when we're given information like that, so that everything is on the same period basis, and then we can do the math and we'll be all good. So we're going to cover that today. So the main thing here in these problems where we're looking at using APRs, annual percentage rates, and usually in those cases, you know, the interest rate is quoted over a year, but the compounding happens over a smaller, shorter time period, like a day, a month, or a quarter. So we have to do some conversions. And the things we have to look at are converting to an interest rate that is expressed as an interest rate per period, per compounding period. And the number of periods also have to be expressed in terms of the number of periods where the compounding or cash flows takes place. And the key is, you know, that we have to keep that definition of the period consistent, right? If your cash flows happen once a year, then your interest rate and the periods that you measure must be on an annual basis. If your loan payments happen once a month, then your interest rate has to be based on per month, and the number of periods has to be the number of months. So for example, up to now, right, we're given an interest rate per period or per year, and then we're given the number of periods or number of years. So there was consistency how the interest rate and the number of periods were given. If it was on a month, up to now, all the examples we had, you're given an interest rate per month and the number of months. So, and this was the example that we did before. This is the same one we did last week. I haven't made any changes to it, right? We had a $200,000 condo with 100% financing over 30 years, 10% interest per year, annual payments, so everything's on a yearly basis. And that's what the timeline of cash flows look like, right? And then we had to figure out what the payments were. And so we looked at two ways. One was using Excel, and then we put in the interest rate here, the number of periods, which was 30 years. Interest rate was 10% per year. The present value in this case was $200,000, the value of the loan that we got. And then the value in the future of the loan was zero after we paid it all off. And that gave us what the payment was. And I think we got 21,216. Again, we've already done this example. This is not new. I'm just kind of reviewing this before we start changing some of the things in the question. We also can do the math, and this is what the math formula looks like. There's a couple more keystrokes, but you should get exactly the same answer. And in this case, you solve for C, and you get 21,216 as well. So you need to do a little algebra on that one, solve for the variable C. Okay, so that's all old news. Let's look at something new now. What if the interest rate and the payments are given over different periods? So I changed the problem now. So now it's still a $200,000 condo with 100% financing over 30 years, but now we're given a 10% APR. And we're making monthly payments. So this is pretty representative to the way mortgages are quoted today. When you're quoted an interest rate for the mortgage, it's typically an APR, annual percentage rate, and payments for mortgages are typically monthly. So why don't we calculate this problem given this new information? So right off the bat, right, we have to think about the period being the same as the period when the cash flows are given, okay? And the cash flows are monthly, So that means our period is 1 month. And how many months are there in 30 years? Turns out 360 months, right? 30 times 12. 30 years times 12 months per year. So the first thing we have to do now is we have to convert that 10% APR interest rate, and we have to convert the 30-year financing schedule into the number of periods that we're going to have. So the first question then is, what is the monthly periodic rate for 10% APR? This is the formula that we covered last week. The APR equals the periodic rate multiplied by the number of periods per year. In this case, 10% equals the periodic rate times 12 periods per year. So we'll just do a little algebra, and we can solve for the periodic rate, and it's going to be 0.00833. So that's that interest rate R that we need in our math calculation or in Excel. Right, so usually whenever you see an APR quoted, you're going to have to convert it because that's not the interest rate we use for all the math, right? It's merely a way to annualize interest rates so that consumers can compare different financing offers, basically, or investment offers. How many periods in 30 years? We've kind of done that already, but it's 30 years times 12 months per year, so we've got 360 months. So that should be enough for us to then go ahead and recalculate this problem with the new information. So here's the problem statement again. $200,000 loan, 10% APR, monthly payments. So let's go ahead and solve it. We know that the rate is 0.00833. We know the number of periods is 360, right? We've already got that. So here's the Excel formula to solve it. And we're solving for the payment, P-A-Y-M-E-N-T. Excel just calls it PMT. And here's the rate R. Here are the number of periods, 360. Here's the present value, and here's the future value, okay? And so this will give us 1754. So that's the new answer, assuming monthly payments in this loan instead of the annual payments we did in the previous example. If we go ahead and do the math, it's going to look something like this. A little of an eyesore here, but we've got the $200,000 present value is equal to the periodic cash flow or payment multiplied by this whole quantity, 1 over R, 1 over the interest rate, minus 1 over this whole term right here, R times 1 plus R to the power of the number of periods. Okay? And both ways should give you the same answer, 1754. Any questions on that one?
Yeah, I have a question.
Go ahead.
On the problem, was the rate given, or did you have to figure out the 0.00833 per month?
You were given 10% APR. And so then we had to convert that into a monthly interest rate, basically. So we had to figure out that monthly interest rate. And it's fairly easy. 10% APR means it's annual. So then you just divide it by the number of periods per year. And since these are monthly payments, we have 12 months per year. So you take that 10% and just divide it by 12.
Oh, okay, so is the 10% divided by the period. So in this case, it was the 360, right? Because it was 5 years or 4 years, something like that.
Well, 360 is the total number of periods over the whole loan. But when we're talking the interest rate, we have to figure out what the interest rate is per period.
Oh, okay.
Right, and that, if you look up what I'm sharing with you right now, that's the process we went through to get that 0.00833. We use that APR equation that we studied last week.
Oh, okay.
And then you just plug in the APR, you plug in the number of periods per year, and then you have to solve for the periodic rate. But you'll see here what the periodic rate basically is. It's basically the APR divided by the number of periods per year. So we were quoted 10% APR, right? Here's 10%, and there are 12 months per year, so that's the monthly interest rate right there. So,
thank you.
Let's do another example here. So this one's a little different. This is going to be present value, and we've got $10,000 in 12 years, so that's the future value. We've got a 15% APR. Oh, and this one's a little different. We have quarterly compounding. Okay. So what do we know? Well, with all these time value of money APR problems, we have to convert the number of periods, and we have to convert the interest rate, right? And so in this case, the number of periods is 12 years, and then we have to convert that into quarters because of quarterly compounding. So how many quarters do we have in a year? Looks like 4, right? So 12 years times 4 quarters or 4 periods per year. So we've got a total of 48 quarters in this problem. That's the T, if you will. And then the interest rate. The periodic rate is just going to be the APR, 15%, divided by the number of periods per year, 4. So it's 3.75% every quarter. Okay. Any questions on the number of periods or the periodic rate? Here's the solution in Excel, right? We're going to use the PV formula since that's what we're looking for, the present value. And then the first thing we put is that periodic rate, which we just calculated as 3.75% or 0.0375. And then we put in the number of periods, the total number of periods, 48. And then in the PV formula from Excel, the next thing it asks you for is there any periodic payments? Are there any cash flows that happen every single period? Excel calls that the PMT, right? And so that's 0. We don't have that. We only have one lump sum at the very end of $10,000, and that's what goes here at the end of the PV formula, the future value. So you go ahead and calculate that. You should get 1708. And then if we do the math, we can just do the simple PV formula. PV equals the future value, 10,000, divided by 1 plus the interest rate, all to the number of periods, total number of periods. So the interest rate is 0.0375, and the total number of periods is 48. And we should get the same answer. I'm going to walk through this example in Excel. And this might be a good way to solve a lot of time value of money problems. If you like doing the math, you can still use Excel, but you can type the formula in here. Okay, there's our problem. And so we can just go through. There are like 4 or 5 different variables that every time value of money problem has, and usually the way it works is you have to find one of them, but you're given all the others. So as long as you just go through that checklist, like for us, PV. So PV in this problem, that's what we have to solve for. So I'm going to put a question mark there, okay? The next thing would be FV. And in this case, we know FV is $10,000. Actually, I'm gonna write this another way. I apologize. So FV's $10,000, right? And PV, we don't know what that is. The other thing we have to figure out is the number of periods, right? Or the interest rate. So let's say 0.1 R, the interest rate, is going to be 0.15 APR, right? 15% APR. Are there any payments, any payments that are made every single period? In this case, no, that's 0. And the last one is the periods, and we know we're given 12 years. Okay, so what we need to do, we're calculating present value, and the quarterly is our period, right? So let's go ahead and convert this. Let's convert this to a quarterly interest rate. And so that's going to be 0.15 divided by 4. Okay? Because 15% is an APR, annual percentage rate, and we can just divide it by the number of periods per period, or per year, and it will give us that periodic rate. And the number of periods is basically going to be equal to 12 years multiplied by the number of periods per year. And in this case, there's 4, right? Because it's quarterly. So that looks like everything we need. And now we can go ahead and we can calculate the present value. And I'm just going to use the present value formula in this instance here. And then we can look at the other way to do it again as well. So our interest rate here is basically this one right here, right? D9. So in Excel, you know, instead of writing out the numbers, you can just input the cell where the number is. So I'm going to go ahead and do that, and then it's comma. And you can see also right down here in Excel, do you see how it gives you a hint on the information to put into the PV formula? So the next thing is the number of periods. And I will try to make this screen a little bigger for you. Maybe it'll make it easier for you to see. So there's the number of periods, and I'm just going to click on that, and so that'll make it a little easier for us. The next thing we need is the payment, and there is no payment, so that's going to be 0. Okay. Now we need the future value, and the future value we said was 10,000. That's right here. So that should give us the same answer right there, just like as if we put the actual numbers into the formula. But this is pretty handy because most everything you might do in a company setting, when you use a formula or do some math calculations, you're always going to be referring to cells inside your math calculations or formula, just like I did right here. Any questions on that before I hit enter? Let me see, I think, where's my chat? Doesn't look like it, so I'm gonna go ahead and hit enter here. And there's that same 1708. And now I know some of you really like to do the math instead, and you know the math is pretty simple here as well, just to do it in Excel. But I imagine you might be used to it on some of those TI calculators you have, and that's fine. So the PV in the math formula, right? It's going to be future value divided by 1 plus the interest rate, right? All to the power of the number of periods. So that'll do the math for us, but we can still do it in Excel, and hopefully it'll give us the same answer. Looks good. I just want to point out one more thing to you in case you're wondering. You might be tempted to put more parentheses here to make sure that Excel does that whole calculation in the denominator of that fraction fast by itself. But whenever Excel goes through calculations, it always does exponents before multiplying and dividing. So you don't really need to do it because it's going to do that exponent before dividing it into the number. That's this one right here. So you don't really need these exponents, these parentheses, sorry. It'll do this calculation here before dividing it into this number here. Any questions on that?
From where did you get the quarter interest rate?
So what I did here is I took we were quoted a 15% APR right here. Do you see that 15% APR? That was in the question. And then we were told we had quarterly compounding. So you can't use APRs by themselves. You have to convert them to a periodic interest rate to the same period whenever the compounding happens or the cash flows are occurring. And in this question, we're told that it's quarterly compounding. So that means since there are 4 quarters in a year, it's happening every quarter, every 3 months, basically, right? And so how do we convert an annual rate to a quarterly rate? And we have to divide it by the number of periods per year. And in this case, there are 4 quarters per year, just like there are 4 quarters in a dollar. Okay, so we divide that annual percentage rate by the number of periods per year, and that gives us that, that periodic rate, or in this case, the quarterly interest rate. And you can see in the example right here, we did this. Here are the number of periods. So this is the original example where we calculated that periodic interest rate. We start off with the basic APR equation. Annual percentage rate equals the periodic rate multiplied by the number of periods per year. 10% equals the periodic rate times 12 periods per year, because in this example, the APR was 10%, and the number of periods per year was 12 in the previous example to this one, okay? So in that case, we just took the APR basically and divided by the number of periods per year. In that example, the previous example, it was monthly, so it's 12 periods per year, 12 months in a year. So you're given annual percentage rate divided by the number of periods per year, and that gives you your periodic interest rate. And I think that is it for the slides.